Dear students, today we are going to discuss about water technology. This chapter covers different type of waters and different type of hardness and estimation of hardness and removal of hardness. Actually, the water is classified into two types. One is hard water and other one is soft water. Hard water. Hard water is nothing but the water containing too much of calcium and magnesium salts. The hard water does not produce any lather with soap solution. Why the hard water does not produce any lather? Actually, the soap solution containing sodium citrate. The sodium citrate is reactive with calcium chloride is present in your water. It forms calcium citrate. It is insoluble in water. So, it does not produce any lather with soap solution. Here, the sodium citrate formula is C17H35COONA. It reacts with calcium chloride. It forms C17H35COOCA, that is calcium citrate. It is insoluble in water. So next one is soft water. Soft water is nothing but the water containing very small amount of calcium and magnesium salts, as well as some small amount of sodium salt also. This water produce lather with soap solution. Next one is hardness of water. The hardness is classified into two types. One is permanent hardness and other one is temporary hardness. Temporary hardness is nothing but the water contain calcium and magnesium bicarbonates and iron carbonates. This is removed by boiling of water. At the time of boiling, what happened? At the time of boiling, the water, temporary hardness water containing calcium bicarbonate, at the time of boiling, it is converted into calcium carbonate. It is settled. Even magnesium bicarbonate also at the time of boiling is converted into magnesium carbonate. It is also going to settle down. So, the temporary hardness water, we are easily remove the temporary hardness. Next one is permanent hardness. The permanent hardness due to presence of chloride and sulfate salts. The hardness are denoted by some different units. The example, the hardness is denoted by ppm and milligram per liter and degree Clerk and degree French. So the hardness we are denoted by using these units. Next, we are going to discuss about how to estimate the hardness of water. The hardness of water has been estimated by Edta method. The Edta, I think you know about Edta. Edta is nothing but ethylene diamine tetraacetic acid. CH2 bond CH2 bond N. This is ethylene diamine tetraacetic acid. Actually, this is not soluble in water, but in the disodium salt form of Edta is soluble in water. Next, what is the principle for estimation of hardness? The principle of estimation of hardness is the amount of hardness making calcium and magnesium salts are estimated by using EDTA method. The amount of hardness causing calcium and magnesium salt containing water, the amount of hardness causing ions titrate against EDTA by adding EBT indicator 1 or 2 drops with 4 or 5 drops of ammonium buffer. We need to maintain the solution at pH 8 to 10. For maintaining this pH, we need to add ammonia buffer. Ammonia buffer is nothing but ammonia chloride, NH4Cl and NH4OH, ammonia chloride and ammonia hydroxide solution. This is known as ammonia buffer. Why we need to add ammonia buffer in this solution? Ammonia buffer maintain the solution pH from 8 to 10. In this pH only, this reaction is going on. It forms only complex. In this pH only, this forms complex. After adding EBT, the water sample changes to wine red color. And then after titrating against EDTA, it is converted into deep blue color. Now the question rises, why it forms wine red color and why it forms deep blue color after titration? Actually, after adding EBT indicator, the EBT is reactive with calcium. It forms a calcium EBT complex. It is wine red color. So your water shows wine red color. After titrate against EDTA, the EBT is replaced by EDTA. So it forms a calcium EDTA complex. Actually, it is colorless. But the EBT color is deep blue. This free EBT shows deep blue color in the final titration. So we easily identify the titration endpoint from wine red color to deep blue color. So now we go to titration. Actually, the titration having 3 different parts. The first part is standardization of EDTA. The second part, estimation of permanent hardness. And third part, estimation of total hardness. So totally this estimation covered by 3 different titrations. The first titration is standardization of EDTA. The EDTA has been standardized by using standard hard water. The 20 ml of standard water is piped out into conical flask and add 2 to 3 dabs of EBT indicator and 5 drops of ammonia buffer. This solution is titrated against EDTA. The color changes from wine red to deep blue color. At the time, note the reading. That reading is V1 ml. It is a first part. In the second part, we are going to estimate the hardness of water. That means permanent hardness of water. For estimation of permanent hardness, just we are taking 20 ml of your water sample. In this water sample, we are adding EBT indicator and ammonia buffer. Now the water sample is converted to wine red color because of EBT and Ca complex. This will be titrated against standardized EDTA. In the first titration, it is normal EDTA. It is not standardized. Now it is standardized. So the solution is standardized. The solution is titrated against standardized EDTA. At a certain point, the solution color changes from wine red to deep blue color. So note the reading, that is V2 ml. And then the third part of the titration, we take the water sample, boiled it up to 15 to 20 minutes. Now what happened? The temporary hardness is totally removed, because we already know the equation. The temporary hardness making ions calcium and magnesium has been removed by boiling. So for estimation of permanent hardness, just we remove the temporary making ions, calcium and magnesium by boiling. Now your water containing only chloride and sulfate salts. Now just filter the samples and take 20 ml of that filtered sample, add EBT indicator and ammonia buffer, titrate against EDTA, the same endpoint from wine red to deep blue color. Just note the reading for third titration, that is V3 ml. So now you have three readings. One is V1 ml for standardization of EDTA, and then the second one is V2 ml for estimation of total hardness, and then the V3 ml for estimation of permanent hardness. By using this V1 ml, V2 ml and V3 ml, we easily find out temporary hardness, permanent hardness and total hardness. Now we are going to enter calculation part. Now you have three readings. One is V1 ml, the second one is V2 ml, the third one is V3 ml. We are now entering into calculation part. The first calculation part is standardization of EDTA. Actually 1 ml of standard hard water consumes 1 milligram of calcium carbonate. So 20 ml of standard hot water consumes 20 milligram of calcium carbonate. So 20 ml of hot water consumes V1 ml of EDTA. So 1 ml of EDTA equal to 20 divided by V1 milligram of calcium carbonate. In the second titration, estimation of total hardness. 20 ml of given hard water sample consumes V2 ml of EDTA. So V2 into 20 divided by V1 milligram of calcium carbonate equivalents. So 1000 ml of, that means 1 liter of hard water consumes 1000 into 20 into V2 into 20 divided by V1, that is 1000 into V2 by V1 ppm. By using this formula, we easily find out total hardness of the water sample. In the first titration, by using this formula, we easily find out the standardization of EDTA, easily find out the normality of EDTA. And then the second titration, by using this formula, we easily find out the total hardness of water. And then the third titration, estimation of permanent hardness. For estimation of permanent hardness, just you are boiling the water, just the temporary making ions are settled down, just filter it, take the filtered sample and titrate against EDTA, you are getting V3 ml value. By using this V3 ml, we make this calculation. 20 ml of sample consumes V3 ml of EDTA. So V3 into 20 divided by V1 milligram of calcium carbonate. So 1000 ml of hard water consumes V3 into 20 divided by V1 into 1000 divided by 20. So 1000 into V3 by V1 ppm. It is known as permanent hardness. By using this formula, we easily find out the permanent hardness of water. Now we have total hardness and now we have permanent hardness. What about temporary hardness? It is very easy. Just temporary hardness is nothing but temporary hardness equal total hardness minus permanent hardness. Do you know already? Total hardness and permanent hardness. Just substitute the value in this equation. 1000 into V2 by V1 minus 1000 into V3 by V1. So just 1000 V2 minus V3 divided by V1 ppm. By using this formula, we easily calculate the temporary hardness value. So by using this titration, we are able to calculate temporary hardness, permanent hardness and total hardness. So already we discussed what is known as temporary hardness, what is known as permanent hardness. So we easily find out this permanent hardness and temporary hardness by using this titration. So next topic is how to remove this temporary hardness and permanent hardness from the hard water. It will be discussed in next video. Thank you.